Hello Abaqus user, welcome to Abaqus Acumen for quick and sound learning. Today we are going to do 3D contact. So like a two solid disk and they are having a contact with each other. So this particular problem will solve it, and we'll see right now what you see, the how much is the stress generated, how much is the plasticity, and important learning will be how we will define a contact. So let's see. The other thing you'll learn in out of this is like we have very fine mesh here in the contact region. So that's what actually we'll try to do it. You can also do a lot of steps like cut and see how is a stress generated. So it started with a line contact and then it's become a area contact. So this particular problem will try, and like two discs, I'll just measure what is the thickness. So this is like 2.5 millimeters. So we'll try to solve this problem. So let's go to the drawing board and understand what is the problem. So this is introduction to Hypermesh Pre. This is Abaqus tutorial number 4, but we already cover 105 different videos on Abaqus. We are going to focus on 3D contact, disk to disk contact. That's what actually we'll do. So there are two disks. The both disk ID is inner diameter is 10, and then OD one is 30 and other is OD is 20 millimeter. So this is in millimeter. So the units which we are going to follow is SI units. So mass will be in ton, force will be in Newton, geometry and displacement in millimeter, and time will be in second. So if you see the material property like this is in MPa all. So you have modulus of elasticity and then you have plasticity data. We'll have a contact with 0.2 friction between the two disks, and the smaller disc, the top disc, will push by 0.1 millimeter, and then we'll see how is the contact stress zone and how the stress generation mechanism, and then we'll also try to find what is the plasticity data. Since we are using a plastic strain data, so we'll measure how much is a plasticity generated there. So this is a problem we'll do, and we'll try to solve this problem. So let me first go to the Hypermesh. So if you open Hypermesh, we have Hypermesh version 13. So if you open a Hypermesh, your default may be Hypermesh. So untitled Hypermesh. Then you go to the first thing, go to the preference, go to the user profile, you go to the Abaqus and set first for 3D. Why 3D? Because we are going to solve problem is a three-dimensional problem. It is a solid element we are going to use. So it is not a two-dimensional plane stress or plane strain or axis symmetry problem. This is the three-dimensional problem. So we'll use standard 3D. We are going to try to solve in implicit one, so not explicit. So we are not selecting explicit one, it's implicit. So we select standard 3D. So you select the standard 3D, it will change the template. So as soon as you load, it will load the template, and then all this, the parameter, it will just change it. So we done that. Now what we'll do, I'll just first quickly use a F8 function F8 key, and then I'll just put a 0 0 0, the first coordinate. And then what I'll do, I'll just create a component, say disk 1, and I say geometry. We'll create a quick geometry here, and I say create, and then I go to line, and then I go to the circle, and then I just want about See, so I just go and put there, and my ID is 10, so I put a 5, and then I'll put 15, and then I select the, so I created the disk. So I created a 2D of disk. Then I'll just copy this, because copy this by 25. So shift, I'll do shift F4, and I say node, and I say node duplicate along Y, and I'm just copying it by 25 millimeter. So because there I'll just create one more. I'll create disk 2, and then line, I select this and I put this as a 10. So this is my OD, and then I just put 5. So that way I created this. So I'll just quickly do one thing. Again I use function F8, and then I go to line and I say 5 nodes. So I created the 5 nodes on all these lines. So I select the line and press a center button, so it creates. So I'll just create this line. I'm going to create this particular line, and then I'll also create line for this. Now why I'm doing all these things? I'm doing this because just I want to do a good quality meshing in this. So that is the reason I am doing it. And then I'll say line edit, and then I'm going to split a line. So I select both this line, I say cutting, and then I'll split it. Then I select both this line, and then I select this and split it. So now if you see, if I have to do 2D mesh, say rule by line and say by line. So I select this. So let me select first 2D. I'll do D and remove the disk 2 geometry. I say disk 2 geometry I don't want, and then I do shift F2 and I'll clear it. So I'm going to do now focus on meshing part. So I'll go to 2D rule line list, and I say without surface. Why without surface? Because I want to have a good quality structural mesh. So I'm just going to choose point 125. I'll see how it looks like. So it will be very fine. So let's have something like 2.5 recall, then mesh it. I'll go for 1.25. This is quite good mesh. Still will do the refinement. I'll also then put the second one on, and I'll click here. So what you do, you click here and then go to the disk to geometry bucket or folder. I'll put here rule again like this and like this, and I say 1.25. let's mesh it. Now this is how it looks like, but I want to have quite a fine mesh here. So what I'll do, I'll just go to this and let me first delete this element. So I take like I'll delete this like this. It takes I'll also delete this, and I select this by face and delete it. And I'll again quickly construct one more line. I'm just constructing line like this because I'm going to split that circle, and I'll also, so what I do, I'll just remove the nodes. Now I just construct this. This is for splitting the line. So I select the first line, and I select the first line, I select the second line, I select the cutting line. and then I select the first line, second line, and I select this cutting line. So I have now quite a bit fine mesh there. So now I create again 2D rule, and then I select this is my first, this is my second line, and create. This will be 1.25. Now I don't want 5, I want like something like, I'll say let's try 10, how it looks like 10. So 10 is far better actually. I'll say 12. So you get a quite a fine mesh here. Now if you look here, the mesh is quite a bit fine compared to the other one. I'll also then quickly finish this this one and this one, and I'll say 1.25. You can also go to O, you put a O command and then go to the mesh, and you can put here 1.25 as a, so every time it will not create the issue. Now what I do, similar like that, I'll also delete this one and this one, and I select this by face, delete, and then similar procedure will go. I'll just go to this collector, will quickly construct the line, and then I'm going to geometry line edit. I'll select this and this, and then I use this cutting line, split it, and then I'll just select this and then select that and say okay, you got this, but I'll go for at least 9 element. I'll say let's go for a 10. Then will be quite compared to finer, and then we can also have like a, we can go for 12. I think that will be better for in terms of, so the mesh is very important in this. So if you see the normal, they are not same, so I'll also shift F10 I'll do, and I adjust the normal, so they are not merged still. So let me first also finish the, so we finish. Now we'll take one by one. So I don't want a geometry, so I say none, and an element I don't want this, so I'm just going to focus on this. So first thing, now we are going to do a merging part. So what I'll do, first go to tool, go to the check element and check what is a 2D length. So it's a 0.2 is a minimum length is there. So then you do shift F3 and say 0.1 is enough for me, and then you say element display preview equivalence. So this is not equivalence, so you do equivalence, and then you check the find edge, and then you remove it. So you might get just outer feature of that, so there is no issue, it's perfectly merged and you get outer finish. So delete the edge. Now you put second one, again go to tool, check element, check the length, it is 0.3, and again you can go up to 0.3. so element display preview equivalence, so done, find edge, and then you get outer, so it's perfectly fine. So shift F3 and I'll delete edge. So now I'll just check the shift F10 normal for this. I'll just adjust the normal. I say adjust the normal. Now you see there are two already parts are done. So I want a 2.5 millimeter thick. So what I'll do, I'll create one more called disk 1 solid. I just given a name solid, and then let's select this some color, and you say 3D drag element by collector, you select that, along Z and distance is 2.5 millimeter, and we want two elements. If you want more than two, you can do it. Then I'll just create a disk 2 and I choose some color and I say 3D, again drag element by collector, and I just we have two solid element. Now we'll check a solid element connectivity. How to check the solid element connectivity? Go to tool, go to faces and just check the faces. Get faces. So once you've done that, get the faces, you just select the face and do shift F3 and find whether you should not get any free edge. So no edge found, selected element. They are enclosed volume. This is one indication, and the second is also check a T connection. No T connection, that means your solid element have connectivity. Now tool, again faces, I'll delete the faces and then I'll open the new one, the other one, and I'll select this and I'll say find faces, and then we'll also check for this find edge, no T connection and no this, so it's perfectly fine. So we'll delete both faces. Now we have modeling part, meshing part we done. Now we'll quickly create a material data. So material is a steel. We are going to use 315 KSI steel. So let's have elasticity data 210 e power 03, Poisson's ratio 0.3. Then I'll put a plasticity data. So you say plastic data, and then I just want to use a 7 different cards. So 315 is 0, 380 is a 0.1, then 430 as as a 0.2, then you have 485 as a 0.3, then 590 as 0.4, and then 690 as 0.5, and then you have 800 at 70% strength. So it's a high grade steel. And then let's create create as a disk. Both are same materials and solid, so we don't have to create a separate thing for this. So solid section, you select steel and say create, and you already have those. So we'll just quickly update both this component with property which we have created. Now this is cover everything, so this is almost done. Now only thing what I'll do, I'll just rename these are shell element, and then we also don't want this to export, so just put this hyphen sign to it, so it will not export, at all. So if you put this hyphen sign, it will not export. So we just generated that. We'll now quickly generated the master and slave. So the master and slave, the general guideline for the selection is the stiffer material will be master, coarse component will be the master one. That is what is the guideline. Now both mesh are same and both are same material, so applicator part will be the master. So since it is going to move down by 0.1, this is going to apply load on this, so applicator will be the master for this case. So I'll say tool faces, I'll select this, find face, and I say none, and I just this. So this is my master, so I'm going to generate a master here. So I'll say, I'll go to the interface, I'll say master, and I'm going to select surface element and some color I'm going to select, create and edit, and then I'll just add the element. So I want all these elements should be added in there. So I added. So now you can tool and then go to the faces and delete the faces. So you already have the group there created. Now similarly, we'll also create a group for slave for disk 2, sorry, disk 1, which will be slave part. So I'll go to tool, faces, and then I select find faces, and then I go to slave, create and edit, and then I just add the element. So I added, and then as a tool, faces, delete it. So now we have the two groups. So you see there is one group and both the two groups are there. Now we'll quickly create the fiction property. For that you have to go to property card and say freak, whatever name you want to give, and then you select surface interaction is a, so surface interaction, you don't want a material data for this. So you say create and then you put a friction of 0.2, sorry, 0.2 here. Now we are almost done. Now let's define the contact. Now this is like you define contact, you select contact pair, you select some color, color is not important here, you select the property friction, you select the slave surface, you select the master surface. So we done a full, now we define now everything. I'll just save it, file, save as, and I say disk to disk contact. Now the only thing is we define everything. Now we have to still define the loads and boundary conditions. So I'll first define here. So let me first put a group off. So what I do, tool, faces, I just select this particular thing, find faces, and I'll say off, and then load, sorry, I go to the component faces and I say F2, I select by face delete, and I also select this by face delete, and then I say disk 1. This is actually all translation constraints. So analysis, I go to the constraint and I say all translation constraint on this node. So create. So we constraint all XYZ DOM. Now tool, faces, I delete it. Now I'll put this 2. I say tool, face, sorry, tool, faces, I say component select, find faces, and then I also do one thing, I'll delete this. This is I'm deleting by, because for selection it will be easy for me. Now I'll do this 2 boundary condition, I select some color, and I say analysis constraint, and I'm going to put this by 0.1 down. So along Y 0.1 down, others is constraint. So create, we done that. Now tool, faces, delete. Now we have everything. We have created the 2 component, we also define the contact, friction, we define the boundary condition. Now we quickly created the load step. Before load step created, we'll create an output block. So it will be output, create, and then we'll edit it, and then we'll have output variable equal to pre-select, frequency is equal to 1, and then we have nodal output, will have element output, and then we'll define the step. So analysis load step, I say contact, I select the first boundary condition, I selected the output block, I say create, and then I say edit, and then here we'll put a static, we'll put a name, nljom on, increment will give like 100. If it doesn't get converge in 100, then it will not going to converge. And then we put a data line like a 0.0, sorry, 0.01, and let's both boundary condition output block is there, so we almost done. So let's save it and then just export it and then see how what we get out of this. So we export it. Now I can do it from here. So you go and go to the Abaqus command, then I go to the D folder, and then I say cd and I say abq6145j is equal to, and then select the file name. You select the file name without inp, and then you put interactive command. So let's see what happened. The run start, and then it just started. Then once it crossed the pre, then we'll just have a look how the inp file looks like. So it gone to the pre, it gone to the standard. Now let's check how the inp file looks like. So you have nodal data, sorry, you have C3D8R disk 1, disk 2, you define the property for those, material data, friction, then we have two contact surface, static, nljom on, then boundary condition for both, and output block. So you define that. So it just completed. So let's see how it looks like. So let's open our new run which we just finished. So let me first put this, and let's first go and check one mice stress. So I'll do first simple averaging algorithm. So this is how the stress is there. So it's 135, and then you can also check plasticity data. So you check a plasticity data, how is, so let's put this like a 4. So around 2%, around 2.27% plasticity is there generated, because it's just a line contact. So all the load get transferred on a line, and then you can also do a lot of things, is get a cut and check how it looks like. So this was a quick problem on the solid contact. I hope you liked the video. Don't forget to like us and subscribe us. Thank you for watching this video. Thank you. Bye bye.